So I thought we'd loop back around and cover the next things I'm going to try with this Atari monitor. I lost a previous video segment where I actually did the work to get to this point, so I'll recap that quick. I took the unit apart. I've got all of the nuts and screws and everything here. Got it on the bench, and again, I don't have a service manual, so I don't know how safe what I did is or isn't. I have a line cord here with alligator clips on the end. This is a pretty dangerous object, and then I can plug it into the wall, and I've got 120 volts exposed here. Could hurt yourself pretty bad. On the main PC board for this monitor, make sure this is in frame. It's really not. Let me adjust the camera a bit here. I've got a yellow jumper lead across where the main power switch goes. There are 3 places on here where the connections to the power main end up. One of them is I believe this is the earth ground. We've got the AC power inputs, and on the back they are labeled white and black. If I remember correctly, white is typically the neutral on house wiring in the US, and black is actually the hot, as counterintuitive as that is. And again, don't quote me on that. But I have attached the black to the black post, the white to the white post, and got a ground on there. So I use this to get power to the monitor, and like I said, the jumper switch, or the switch has been jumpered with the yellow lead here. I want to get this high voltage lead out of the way. I don't want it to crank up and throw, you know, thousands and thousands of volts back into the board and fry the board. I will say I don't know all the ramifications of powering this thing up without all the controls attached, and I know this could be a dangerous lead here, but the idea for this for me was to get a look into the power supply, determine if I thought the power supply was working. I'm using an isolation transformer back here, so I at least have the primary voltage out of the wall isolated through an isolation transformer. The earth ground, however, does pass all the way back through, so I do have earth ground all the way back through, and that of course is the neutral. It should be at earth ground potential, but still again it creates, you know, a potential hazard. Anyhow, I got to this point, I powered it up, and I started to probe around, and I don't know if you can see it here. I tacked a little piece of wire on the negative pole of this capacitor, took my voltmeter, this is that main filter cap we replaced, and got myself a ground reference, and then with it powered up, I walked through the incoming voltage, so I could see that the 120 volt was coming in. I could see through this, I think it's an inductor that the voltage is being passed through. Anyhow, I could trace the power through this way, through the diode bridge back here, the diode bridge that comes down, and eventually to this filter cap. And there was 160 volts DC across this filter cap, which told me at least this piece of the supply is working. I'm getting this 160 volt DC across this cap. And then I started to move through the circuit here to get over to where the transformer is, out of the power supply to the main board. And I'm guessing this is kind of a switching power supply setup, maybe. I don't fully understand. Again, I don't have a schematic. But I started to poke around in here with the voltmeter on DC and wasn't really finding voltages any place on the transformer. I went to AC mode and I looked for AC as well and didn't really find anything that I expected to find, yet I saw the 160 volts at various places here. This kind of led me to looking closer at this, and under the board, or on the board up against a heatsink, was this STR53041 5-pin device. It's a semiconductor. The device itself looks, you know, it's not been blown up. There was a mica sheet on the back of this between the heat sink to isolate it from that heat sink. So I've captured that mica sheet, and it's here in this little box of the parts I've pulled loose. So I pulled this guy out and went and looked for a data sheet for it. And the only data sheet I found is this one, and it's a pretty lousy data sheet. It's from Sanken Electric Company Limited, hybrid voltage regulator module from 1991. It's for TV switch mode power supply application, which again leads me to believing this is a switch mode power supply. Hybrid voltage regulator made with a triple diffuse planar transistor, fixed output voltage. So this led me to, this is essentially a switching voltage regulator, with there being the transformer the way this is from the primary input side. And if you can see it here, I'm hoping you can see it, there's kind of a wide clearance path around here. Actually part of it's marked off, but there's a fairly wide clearance path between electronics that drive the monitor and this power supply. And that's another kind of hint to me that it's a switching supply. They're creating this clearance so we're not getting arc over or anything like that, to make it a little safer. So with there being no apparent voltages any place in here, I then went on to, and again I apologize for not getting this on video, of taking my oscilloscope. I went in and I verified with an ohm meter. Pull the lead off here. So with the scope probe attached, there's the BNC here, so with the probe attached, this should be earth neutral. That third prong ground. And so I just verified, again with it attached to the scope and the scope plugged in and powered off, that I had continuity from that BNC barrel back to the earth neutral over here, the green wire, and I do. Part of why I did that is you can pretty quickly destroy the front end on an oscilloscope if you're not careful and you accidentally feed line voltage back into it. There's things you can do that'll just take that front end out if you're not careful. So I became confident then that the neutrals were the same, and so by taking that scope probe here and attaching it to either the earth ground, or in this case the ground over here, I wasn't, just being super cautious. I'm not going to fry anything. So I took the scope, hooked the scope up to the negative of this filter cap, and probed around in here looking for signals. I looked at the pins on the transformer, I looked across the semiconductors, and I found nothing in here that oscillates. Everything here was just dead DC. And what that said to me is the oscillator that ultimately drives the switching power supply either isn't working, or perhaps the driver transistor that we looked at, this driver device, is bad. There's a second transistor in here labeled Q701, which seems to be okay when I look at it in diode check mode, but again a suspect. So I've kind of made the decision at this point that I'm going to replace, if I can find a replacement, I'm going to replace this guy, and I'm going to replace whatever this Q701 device is. There's one other transistor that seems to be kind of active in circuit here, although it's really, again, see if I can point this out. I've got this wide kind of isolation cut around here, and assuming that is the switching power supply in here, there's really no other transistors in here. There's just the switching power supply driver and this Q701. I'm hoping right now one of those is bad. We'll find out, assuming I can get replacements for them. This piece over here with the white isolation marking really is outside of this wide gap, so it says to me it's not necessarily part of the switching supply. There is a semiconductor in it, Q403. I don't honestly know if there's feedback out here, perhaps back through the capacitors. Over here there are a bunch of capacitors here. There's 4 of them that bridge the earth ground over here to ultimately the earth ground on the power supply, or no, actually no, on the hot side, what I believe to be the hot side. Anyhow, the line cord comes into the power supply here. Hopefully this is in camera. The fuse is sitting behind right here. Let me get this lead out of the way. The fuse is sitting across here. It comes in through a filter or inductor of some kind here. Again, I don't know what this L701 is. It does say L, so it's some kind of inductive device. Comes through, comes over to this capacitor that couples across to here. Trying to remember the path this flowed. Again, I'm getting a little confused looking at this from the underside. Yeah, it comes across this bridge link here as well. Am I tracing this correctly? No, I'm not. Anyhow, there's this capacitor across here that may be a protection cap of some kind. There are, and again, these are big blue. There's 4 of them here. Get the line cord out of the way. There's 4 blue caps here that I think are just protection devices. You see those around mains input quite often, and the 4 of them are here on the board. But I kind of followed this around. We get to a device here, which seems to be what fires up the degaussing coil. The degaussing coil for the CRT connects across here. And I think this device just simply energizes the coil, and then as it heats up or whatever it does, the resistance increases, and the degaussing action stops because the voltage ultimately to the degaussing coil stops. There's a device here that bridges the switching part of the supply across. It's an inductor. I've looked at the coils with the ohm meter, and the coils all seem, it was an interesting noise, it sounded like a bit of arcing. The coils all seem good. I've looked at kind of continuity across pins on both sides of the transformer, and I find you know pins where I can get continuity. There's an isolated pin here that just goes nowhere, and that was open. There's a couple isolated pins here that are open, but I was able to find continuity between various pins. Anyhow, so putzing around in here, I kind of became convinced that the transformer and the inductors are good. You know, I get continuity across them. Because I just kind of traced this around. I haven't tried to draw a schematic out from this, and that might be helpful. Finding the service manual would be the most helpful. So far, I have not found the service manual. I know now that this is a Samsung monitor. So apparently there was 3 different manufacturers for Atari SC1224 monitors. Panasonic, I believe, I don't remember. This is the Samsung variant, and it just seems impossible to find a service manual for it. I may reach out to Best Electronics at some point and see if they have a service manual for it. I just haven't done that yet. You know, I'm hitting that point where I spent $50 for this monitor because I didn't want to pay shipping on eBay, and it was, you know, unknown whether it worked or not. It of course didn't work. I've invested $15 or so in the replacement caps. Of course, my time. Of course, the time is shooting videos, which is, you know, there's payback there. I don't know. So, you know, I think I'm going to go ahead and pull this transistor out as well. I'm going to do some diode checking on this guy and that transistor out of circuit. And we'll kind of see where that takes us. Don't know if this will honestly tell me anything or not. I've got the kind of equivalent circuit for this switching power supply, regulator, driver, whatever you want to call it. Say this data sheet is pretty skimpy. There is a typical circuit here using it, which I kind of have, you know, I don't know how close this is to this. There's obviously this transformer in the circuit here that would become this transformer. It's really just across the primary on it. There is the switching transistor that's inside of here that is connecting and releasing the power on that primary side of that to turn it, switching it on and off, thus the switching power supply to create, you know, whatever frequency it runs in. In this case, they show 2 secondaries. I believe when I looked at the pinouts here, I was kind of able to determine, I think there's just a center tap versus being two secondaries here. Hopefully I'm not in camera. Two secondaries here. That I think this is just a center tapped configuration looking at it. I think there's only 3 pins that seem to be actively involved. If I remember right, he's isolated, and these two are isolated. They don't go anywhere. So it's similar to this. Inside of the dotted line here is, of course, this device. I'm thinking I can look across pins 3 and 4 on it, which would be pins 3 and 4 would be this NPN device here. And if I don't find a good transistor there, I know this device has failed. I can't really look back through here because there's a Zener diode sitting here in this equivalent circuit, which is, I assume, what's setting the voltage, and an NPN transistor here again. So we'll be, I can't check a diode through here because essentially the diodes are pointing in opposite directions, so you can't get current flow. I mean, it's a Zener regulator. I probably can check this semiconductor in it because it goes from pin 4 to 2. I can't really get to the bases on these. I don't know how much checking I can really do with these. There's a PNP device sitting here. See, I really can't get to the bases to check diode and diode. So again, I don't know how much kind of poking at this is going to do. Probably not going to tell me much of anything. I do have kind of a drawing here that is looking at the device this way, so I know it's pin 1 to the left to pin 5 on the right. Again, this probably isn't going to tell me anything at all, but I'll take a poke. At least if there's shorts, I'll see shorts. I doubt it's shorted. If it was shorted, I would expect the device to have overheated and failed pretty quickly. You know, I keep saying it. I'm guessing here at this without a schematic and with honestly limited knowledge of switching power supplies. You know, I understand the concept, but I don't have a lot of hands-on experience. I will throw this into diode test, not that I expect it to do anything. And if I look at that equivalent circuit, I'm going to look from pins 3 to 4. Which are these two, and I don't expect, honestly. Interesting. So 3 to 4 is looking from collector to base, and I see 1.34 volts in that direction, and open in the other direction, and that may be correct, although it's kind of a mystery to me why collector to base without the device active would necessarily have a forward voltage of 1.1 something volts. Let me go straight to ohms and go 3 to 4. 3.9 mega ohms in that direction, and open in this direction, no surprise. So there is definitely semiconductor action there, or diode action, because it'll pass current in one direction and not the other. Did this really tell me anything? Well, that's a good question. Let's go ahead and look at the other transistor as best we can, and that's pin 2 to 4. And I see, 0.6, I'm on diode check, 0.6 volts, forward bias, and open, again, as negative bias. That's interesting. If I go pin 1 to 5, where we're looking in through the Zener to what's essentially another NPN device, I'm seeing a forward voltage of 1.8, which I find interesting. and a back voltage of 1.7 volts. That's actually kind of odd and suspect to me, at least based on the equivalent circuit. What does this look like in ohms mode? It is 1.8 kilo ohms in one direction and overload in the other, which again says there's a diode effect there. I don't know. As I kind of guess, this isn't telling me a whole lot. I know that looking at the pins on this with the voltmeter, I don't remember seeing anything that made sense. So in the schematic, there's a potentiometer, or no, I don't know what that is. It's a semiconductor of some kind. 13.75 kilohertz drive. That drive is coming to an external transistor here, which is probably just essentially Q701 here. That ultimately this ends up driving pin 2 of the device. Pin 2. What is pin 2? Where's the description of the pins? This data sheet's pretty worthless. Someplace here there was a description of the pins. Why am I not finding the thought? Well, in my mind, I had found kind of a description of the pins. Oh, right here. 2 is base drive, which makes sense there. You know, I didn't find any kind of frequency happening here. I didn't find anything oscillating in here. And without there being oscillation, this switching power supply is not going to work. You know, which kind of pulls it back to me that the issue is somehow in the switching power supply. We've looked at all the diodes in the switching power supply, and the diodes all seem fine. I see, you know, a typical forward bias and an open the other way around. You know, I don't know if it's not getting... In my looking at this, I'm not seeing what I would consider a feedback circuit saying, you know, I'm okay, switcher, come online. There is this inductor here, which may actually be what's providing that feedback. I don't know. I mean, I could be way off the left base here. I have not, and I guess I need to actually go through all the resistors on this as well. I've looked at the large power resistors, but look at them all and make sure I don't have a cracked or failed resistor. But I think I'm going to go ahead and pull this Q701 out, and then I'm, you know, assuming they're not horribly expensive, I'm going to replace both of the semiconductors on the switcher side. Really wish I had a service manual. At least I would have a troubleshooting chart to kind of go through. It might have some pointers at, you know, waveforms, what to expect where. Because I just don't have that at this point. So with that said, I'm going to pull that little transistor out. And as we always do, I'm going to switch glasses so I can actually kind of see what I'm doing here. the soldering pencil, I'm of course getting the solder to flow, and I'm kind of pushing a little bit on the device pin to see the pin actually move, and that helps give me a hint that I have released the solder. He doesn't really want to come out. He's moving. Okay, all the pins are loose. They've just got solder. There it is. So there is that little Q701, and it's labeled C1008. Y-645 means absolutely nothing to me. Part number doesn't ring any kind of bell for, oh yeah, that's a, you know, a 2N2222 or whatever. I'm guessing it probably is just some kind of a common transistor of some sort. Hopefully I can find a cross reference. Got a voltage adjust pot here that I haven't actually looked at. This is the spot here where the big driver device set in place with the mica isolation sheet behind it. I don't recall seeing any other. Only other semiconductors in here are diodes. Yeah, that really is the only other devices. So I'll probably set this down on the bench here, take the ohm meter, and look at all the resistors in circuit here just to make sure they're reasonable. Not a lot of fun troubleshooting this thing, say, without schematic, etc. Like I say, I don't know if there's almost got to be active feedback, almost like a power good coming back to it. At least I would assume that. Just don't know. But anyhow, this catches you back up to where I got to before with this. I will move on to see if I can cross-reference that second transistor. Let me actually get these captured so I don't lose them. If I can get the little container open. So I don't know if you've noticed these containers or not. Where I work, they use a lot of backup tapes. And they end up with a huge number of these little containers the backup tapes go into. And they're just a great little box. They snap shut, they stack. They keep things somewhat organized. And so I've got a huge box of these. And I just kind of use them, as you're seeing here, just to kind of keep things organized and safe. They work really well for that. You know, apparently I have stripped something down at some point. This may even be that reclaiming parts from a switching power supply video I did. But again, all those need to be gone through and got into appropriate part bins. But there's kind of the catch-up video. So, you know, we're moving forward. Tis what it tis. So, with that said, I'm going to flip this over. I'm going to get a look down into the unit itself. I'm going to grab my trusty ohm meter. I could actually pull that board off of there rather than let it float around. I'm sure there's no charge on this large filter cap, but I'm just going to make sure. I'm in ohms, and I'm just going to kind of walk through all of the resistors I can see. We're looking at 0.3 ohms, that's correct. I think I've already looked at all these large ones, but we'll look again. 22 ohms, that's correct. So there's not a lot of resistors down in here. That should be 10. Actually, that's It should be, crap, can't do the math in my head again. It's measuring 0.8 meg, and it's brown, black, green, 10. It should be 1 meg. 100000. Should be 1 meg if I'm doing this right. So it's a little low. It's sulfur tolerance. I'll have to come back and look at that. And some resistors down underneath the heat sink. Luckily there's silkscreen on the bottom of the board, so I can at least can look to say yes, there's a resistor there. That isn't good. Resistor 704. It's just dancing all over the place. That's actually suspect. That may get yanked out of there. .98 ohm. I guess I should flip this over and write down the values from the markings on the resistors, because that one resistor is really suspect. There's 701, 6.8 ohms. Got a lot of glare here from the LED lighting. This is, of course, one of the big power resistors we looked at a minute ago. Yeah, that's that 22 ohm guy. This little resistor right here is rather suspect. Wouldn't it be silly if that was ultimately the issue? It looks like I can pull this heat sink off. Get a little better access down into there. Perhaps should have looked at the more fundamentals first. Screws are captured. That's removed, and we'll now have better access down into there. There's a couple of diodes in there as well. I might as well double check. Get the scope probe up out of the way. Messy bench is a sign of a brilliant mind. So apparently I have a brilliant mind, although I've yet to discover it. So I actually want some glasses with a little more magnification. Make this a little easier to do. That resistor is very suspect. Six, 9, that makes sense. 6.9K. That doesn't make sense. That should be 25K. That is, this resistor here is really suspect too. That's way out from where I believe it should be. Well, I'm going to have to make some notes here and come back and verify again. So I will go off and make myself some notes on what I believe these values should be, and we'll come back and measure them. So I've gone ahead and looked at these three resistors, and there's 170K, a 6.8 ohm, and a 69K in here. And based on the color codes, these actually all measure just fine. I can actually get in here and get contact. Apparently I can't at the moment on this one. So there's R704, and it measures 6.8 ohms, and it's a 6.8 ohm resistor. R703 is hiding right here, and it's supposed to be about 69K, and it measures 68.3K. And then there was the one that was suspect to me, this R704, which is 170K. There's a capacitor someplace in circuit essentially parallel to this. So while I had him actually soldered down on the board, I couldn't measure him. So I just pulled one leg out so I could isolate him. And now that I'm measuring, he measures at 180K. Is that correct? He's a little high, 180K versus 170K marked. So he's actually okay, the one that was suspect. I was looking back through the circuit, seeing a capacitor. The voltmeter works by putting a voltage across the tips and then measuring the current and calculating the resistance from that using Ohm's law. With the capacitor back there someplace, that capacitor is charging from the voltage on the probe tips. And so the capacitor is drawing current. And while it's charging and drawing current, it makes the resistance look lower than it really is. And again, that's why I went ahead and isolated him. So those resistors in there look fine. I didn't actually take a look at that potentiometer. It sets the voltage for the power supply. And it looks like it is a, well, I don't believe that. B-adjust V701. I'm most likely looking back through the circuit again because I'm seeing may not be getting good contact through the oxide. Wiper to one side is 0.2 ohms, and the direct resistance across him is 0.26 ohms. So am I looking back into the circuit, or is he really a very low value resistor? He is a 500 ohm resistor. Most likely I'm looking back through the circuit and seeing something else, but again, I'm just going to go ahead and isolate him. I'll remove him, check him out of circuit. You can probably hear Rosie back there in the background. She'd like some attention. Rosie, shush. She may want water. Her water dish is probably empty. She had her breakfast a little while ago. I'll be there in a minute, sweetie. Oh, she's a turd. And all three legs are loose. It's just a matter of getting him to walk out. So he's supposed to be a 500 ohm pot. Odds are really good that he's fine, but again, yeah, 500 ohm. So again, I was seeing something back through the circuit. Is he completely adjusted to one side? He is completely adjusted all the way to one side. Why would that be? That's really suspect. This pot is turned all the way to one side. And with that being the case, it may have the power supply all the way off. Wow, would that be a nice fix if it was just a pop? And of course, that's why I was measuring almost 0 ohms. Is he is completely turned all the way clockwise. And with him turned all the way clockwise, he's producing essentially a short between these two pins. And that short is going into what is pin, because it's directly into that voltage regulator. And let's see, that would be pin 5. That doesn't make sense as pin 5. Oh, this data sheet's lousy. Let's see. So looking at the board, this is in this orientation, and that is over there on pin 1. I read that exactly backwards. And pin 1 is V out sense. Interesting. That may be the core issue here, is that pot. Somebody has tweaked it all the way to one side. Now I'm tempted to reassemble everything and center that pot and see if that brings the switching supply back online. Didn't even occur to me to look for something like this where a potentiometer had been rotated all the way in one direction. I don't know if that's pulling that pin. So I don't know if rotated this way, if it's the maximum drive or if it's the minimum drive. With it being 0 ohms, where it's adjusted to, my gut tells me that's going to be the minimum drive. But again, I don't know. Well, let me go give my dog some water, and we'll jump back into this in a bit. So I spent some time here kind of thinking about what the next steps on this are going to be. I could reassemble it, center the little potentiometer here out, get it back in the case and power it up and see if it works. The assumption there being, we know we had one bad cap, we had another one highly suspect, and we had other caps that were just not in great shape overall. And kind of make the assumption in that capacitor that was failing, somebody tweaked on here maybe multiple times on the pot, is that capacitor was failing to the point where it just no longer worked. Which kind of brings me back around to the original hope, is that it was just bad caps, and if replacing them it had come back to life. There's potential that that will get this guy back up and running. It would be mount a couple of the transistor and the switching regulator and the pot and get that one resistor with lifted a leg on back in place and get it back in the case and bolt it up. It's a pain to get it out of the case. There's a lot to assemble and a lot of cables to attach to get it back together. If I get it back together and then it doesn't work, then maybe I come around to stripping it back down and attempting to replace the couple of semiconductors on the board here. I think the decision I made is I'm going to reassemble it as is, although I do actually need to make one check before I do that. And that is to take a look at this transistor we pulled out, the little guy. Let me get him out of the little box here. And just make sure we believe he's good. So let's see, he was in... Okay, silkscreen the orientation. Get on diode check up here. And it's pretty standard pinout, base in the middle, emitter and collector on the two ends. I'm just going to take kind of a poke here at it. It's going to be a little bit tricky because the leads are very close together. So I've got a good diode forward that way. And I don't have a diode in the other direction, it looks like. This may actually be a bad transistor at this point. Oh, there it is. So I've got a good... The leads are, of course, flexing around here as I try to do this. I don't want to bend them too much and stress it. Double check that. I should have a diode forward, diode forward, and they're both about 0.6 volts. And then I should have an open and an open. So it looks to me like this little transistor, at least from looking at it through a diode checker, looks good. Hopefully I got that on camera. So I think at this point I'm going to solder everything back onto the board, get it back in the chassis, get it back in the case, center out that pot and see what we get. So, and the assumption doing that is it was bad capacitors that ultimately took this thing down. and somebody tweaking on that voltage adjustment to try to bring it back to life. Anyhow, I think that's what I'm going to do next. Come on. Come on, stop. Well, I've worked my way back through connecting all the cables. I've compared it against the high-res photos. From the photos, I did have this 3-conductor and 3-conductor cable swapped. So I'm really glad I checked the photos and checked every cable and orientation against the photos. I believe at this point we are fully back together. There's no loose wires. The major grounds are plugged in. Really at this point, we are back together, and whether this is actually going to wake up and work or not, I can't honestly say. I'm going to make sure the power switch is open before I plug it in. I'll just do that by getting the ohm meter down in there. And see where I have continuity across the switch. So the switch is on. The switch is off. So I know the switch is open. I'm going to use the isolation transformer again to plug it in. Of course, this assumes I can untangle the nightmare set of leads that come out the back. There's plenty of a cord. This video input cable is very heavy. and stiff. And my first indication of success will be if that power LED comes on the front. And of course the second one is if we don't have smoke and fire come belching out of it. I actually have an extra screw here that I don't know. It goes right there. Let's see if I can wrestle. It's a mounting screw for the board down to the metal chassis, and I think it goes right there, and it does go right there. So I hate it when there's an extra screw, so we will see if we can work that screw down in there and hopefully not lose it. It goes right there. If I can get it down into the screw hole, and there it is. So that one loose screw I had was remaining has been resolved. That makes me much happier than having a screw floating around. So we validated the power switch is off. Moment of truth. And again, absolutely nothing. Stone cold. Wow. Well, as you can see, I'm having absolutely no luck with this. I would have expected at least that LED to light up if there was an operational power supply in the unit. We, of course, have nothing. Well, denied again. I'm going to go ahead and just, because I can, rotate that pot a bit. Don't hear high voltage coming up. Don't hear or see the heater coming on now. Power supply is still dead cold. Well, I wrote down the semiconductor part numbers. The little driver transistor seemed good. The switching regulator suspect, although it seemed reasonable to me. And of course it's impossible this way to get in there and really probe anything. I need schematics to be able to look for voltages in places, like across the filter cap, and I just don't have the schematics to be able to do that with. I'm going to kind of poke around a bit and just see if I can find some gross voltages in places. Let me get on the ground here. And I will look at actually want to be in volts DC before I blow my meter up. A little tricky to get in here and probe. Well, there's 88 volts there, and now it's bleeding off. I remember there being 60 volts or so, I thought, before across this resistor. So there is a gross DC power supply in here. I know we're getting through the bridge to that filter cap. Again, the switch mode just doesn't seem to be working. This really means, I guess, I'm going to go ahead and see if I can find replacement parts for that switch mode regulator and that one little transistor. And it'll get tore down a third time. And they'll get replaced. So, power supply's off. bleeding down to 0 volts. Well, hopefully one of these videos will actually be successful. So far, no luck. We'll talk soon. Bye.